CO2 within an office building or any building is not random, it's derived, and it depends on the number of people there at that moment in time. In this derivation, we're saying that CO2 is equal to 450 baseline parts per million in an indoor office building, plus the number of occupancies times an average of 25 parts per million generated by each person. I got this from ASHRAE, and it's not a random number generator. And ASHRAE is an International Society of Heating, Refrigeration, and Air Conditioning Professionals. All right, so this is what I'm talking about. You can see here in the top part of the chart that in the early mornings there's not really a lot of people. I'm assuming this is a pretty big office, and this might be the cleaning crew. So it's pretty flat until around 5:30, 6 a.m., where I guess the early birds show up to work, right? Because they want to leave early. And as you can see, as we get into 8 a.m., 9 a.m., 10 a.m., noon, the occupancy rises. As we mentioned previously, CO2 should follow the number of occupancies. So as we get more people in the office, our CO2 within the building rises. And this is just our raw CO2. Let's get into the YAML. So it's pretty straightforward to make a derivation. Whatever columns you make here or you specify, you can use within your derivation. And you don't have to put it in any specific order. Odibi will resolve the dependencies on its own in the back end. So, name, CO2 parts per million. We want it to be an integer. And it's a derivation or derived. So the expression here is none if occupancy is none, else, and this is the equation that we have, 450 parts per million plus occupancy times 25, and we just add some noise. You can change this up to whatever you want, and we just round to the nearest, zero precision. Okay, let's run it. Okay, and just like that, and as you can see, CO2 within a building is rhythmic, right? During the early hours, there's not a lot of people, so not a lot of CO2. As we get more people, it increases, and it follows the same trend. And you can see the correlation. As we get more people, we should naturally have more average CO2 parts per million. So in conclusion, we use a derivation plus an expression, and that gives us columns that depend on each other. CO2 does not exist independently of people, and your simulation shouldn't pretend that it does. Thank you.